So welcome to our Apache Maven presentation with Jigar Joshi. I'm very excited to be participating as a moderator and even more excited to introduce Jigar. Jigar, do you want to tell us a little bit about what you're doing and what you're going to be talking tonight about?
Sure. So let me repeat it again. My name is pronounced as Jigar Joshi. I am a software developer. I am very much familiar with Java and related technologies. I work for Lithium Technologies. Lithium is a leading social customer relationship management solution providers in the industry for the enterprises. And in today's session, I'm going to talk about Apache Maven, which is like build and project management and dependency manager for Java projects. So let's get started and let me share my screen. Just figuring out screen share. Okay, so can you see the screen which has the text editor open?
Yes, I can.
Okay, cool. So let's start with the formal definition. Here it says the Apache Maven is a software project management and comprehension tool based on the concept of project object modeling. Maven can manage projects build, reporting, documentation from the central place of information. So this is very formal definition. This might make no sense to you as of now, but it should make sense to you after this session. So let's get started. Like, why do we need it? What is it exactly, and stuff like that. So in the Java world, each project execution needs at least two things. One of them is compilation. One of them is the class path management when you are launching the code. So assume that you have simple hello world Java code, which has simple like one statement of output which prints this hello world on the screen. You're going to Java C class, generate the class, you're going to run the class. That is pretty simple. But now imagine the same thing at the scale of like 50,000 classes. So to manage all the class paths while compiling, while running, it's a problem. So assume that there are no build tools to do it. Assume that there are no dependency manager to do it. How would you do it? So maybe one can come up with the idea that they can homegrown a tool or like write some bash script or something that manages all the class paths from central place of something like config file or something. But again, it's not scalable and it might not work throughout the thing. So some of the people came up with a solution called Ant. Ant is actually a wrapper on top of the shell execution through the Java code. So Ant manages this thing like build, compiling, and the execution part for the Java applications. But again, with Ant, there are some problems which cannot be solved. For example, Ant doesn't get you the dependency management out of the box. There are some plugins, but which are not scalable. Like there are no central place of location from where you can grab the dependencies and stuff. So here we have the Maven. So Maven does the dependency management for you. What does that mean is assume that you have a project which needs the Spring jar. So you can tell the Maven that while doing this project, while running this project, while compiling this project, while executing tests of this project, I need this particular jar in my class path. So Maven will take care of the rest of the stuff for you. You just configure it and Maven will do it by itself. Maven does the project object modeling very nicely. It is like you can correlate it with the object-oriented modeling in the Java world. Similarly, the project object modeling. So here, project you can like correlate as project as an object, which has the inheritance, which has all the stuff that general OOM has, OOP has. Maven has the consistent project structure. So imagine you are working for company A, you are familiar with the project structure. Now you start working for project B for company B. You need to take time to ramp up and to get familiar, like what what source code is placed where in the project structure. Maven has uniform project structure, so you don't need to worry about it, and it's consistent. IDE support. So Maven provides all the IDEs like IntelliJ, Eclipse, NetBeans, and other useful IDEs provide Maven support out of the box through some plugins. So it does the dependency management while compiling in the IDE. Also, it does the build thing while compiling and building through IDE itself. And it has the strong Apache community behind it, and it's in active development. So let's just start on a fresh machine where assume that I don't have anything installed. I'm just going to download Apache Maven for the first time. Let's just go to the Maven site and create the latest stable release, which is 3.2.3 for now. I'll just copy this link. I'm in my home directory. Going to download the distribution from Apache. And Maven is a self-contained software, so you don't need to do the setup at the OS level. You just download it, extract it, and it's there. It's again a simple Java application under the cover. So it is downloading Maven. Let's just okay. It has downloaded this thing. I'm going to extract it. Let's just remove the. Okay, so now I have the Apache Maven placed in my the thing. Find this part to the bin directory to my existing paths, so that now it picks up the Maven from there. And as okay, so as you can see that we have installed Maven, and it's this version. Maven home is this. It's using Java 1.8.0 20 manual release. This is the Java home from where it sets the Java version. These are some other system properties. Okay, so it has installed the Maven. Now let's create a simple Maven project. So I'm going to execute this command. So in this directory, I'm going to execute this command, which says that, hey Maven, using archetype plugin with generate goal, create a project with this particular group ID, this particular artifact ID, but the template project you are going to refer to should be this. And interactive mode is false, so don't ask me any question. This is the thing that we are instructing to Maven to do. It has this 3-term artifact ID, group ID. I'm going to go there just in a while. So let's just first create this project in here. It is invoking Maven's archetype plugin to generate the project. And it has almost completed. Okay. So it has created this project, Maven learning project. This is the directory structure that Maven follows. At the root of the project, it has the pom.xml, which is the descriptor file of the project. This is the standard directory structure for source. Your source classes goes to source main Java, and this is the Java package. This is source class. This is the test class. It goes to source test Java. Again, the package structure and the test class. Okay, so let's go back and look what we did just now. So I ran this thing and I passed these three parameters. So group ID and artifact ID. Group ID, you can correlate group ID with the Java package. So similar kind of project are grouped under similar group under the same group ID. Generally, it's like com.company name. For now, I just placed Jigar Joshi here. Artifact ID is the project identifier. So in this case, it's Maven Learning project. And the third thing that uniquely identifies was is the version. So combination of these three things uniquely identifies any project, any Maven project except for this packaging. So let's just go ahead and import this project. So I created a project in here. I'm going to import in IDE. Currently, I'm using IntelliJ. Right here. Okay, I just imported this project. Let's look at the form.xml file. This is the file from where Maven understands and executes on the project. So the group ID, artifact ID, and the version that I provided. Name of the project and URL of the project. Generally, it should be the homepage of your project. These are the dependencies. We'll get there in a while. So this is the basic project structure that it has created. Okay, let's go next to the dependencies. By the way, anyone has any questions so far? Okay, we'll get that one. Let's go to the dependencies. I'll just go to this. So this form.xml describes that this particular project has the dependencies of this particular artifact, which means that while doing test, this project needs JUnit artifact in the class path. So it will make it available. So here you can see the test class is consuming some packet subclasses from JUnit framework, which Maven makes it available through this instruction. If I take it out, it will start complaining because it's not able to find the classes now. Okay, so let's just go there and make it back. So dependency has these three things that's the artifact identifier in the group and the scope. So each dependency has some scope. So let's go through the dependency scopes. If we go here and so Maven provides 6 type of scopes for the dependencies. First of all is the compile, which means that, hey Maven, while I'm compiling this project, I need this particular dependency in the class path. While I'm running this particular project, I need this particular dependency in the class path. While I'm executing test, I need it in the class path. Provided means provide this dependency while compiling, but I'm going to have this dependency runtime, so don't provide it runtime. Runtime means I don't need it compile time, but I will need it runtime, so provide me at the runtime. Test means that I need this dependency to compile the test classes and to invoke the test at the runtime. System means I have this dependency, I'm going to declare it, but you don't need to worry about it. It's located somewhere on my system, so I'm going to give you the hard-coded file path to the jar. So just place the jar during the compilation. Import, I haven't actually used it. And this is the kind of matrix of scope versus when it is going to be available. Also, you can, so when you say that I need this particular dependency while doing test, so this project might be dependent on some other dependencies as well. Let's guess that this project needs char v while compiling it. So Maven will pull down them as well. If you want to exclude them, then you can write something called exclusion. And you can say that this group ID want this artifact ID. And this way you can exclude that. So it will get everything that this particular artifact and its dependencies except for this. Okay. Any questions so far? If you have any question, feel free to comment in the group chat channel. Okay, I'll move further. Okay, now let's look at the life cycle. So we created a project, we learned about dependencies. Now let's go to the build part of the Maven. So up till now we got the introduction of how Maven does the dependency management. Now let's go into how Maven does the building. So Maven has its own fixed life cycle that it goes through, and it has some plugins attached to each life cycle. So let's see it in detail. So this is Maven's life cycle. It has this set of phases. I'm going to go through each of them real quick. Validate means validate all the pom.xml and other stuff that Maven needs are correct. It doesn't have any syntax error or everything. Compile means Maven compile the source path, source classes which are configured through this pom.xml. Test means execute the test on the test classes. Package means you have now compiled classes. You need to pack them all in particular packaging that can be distributed. For example, a jar. Then integration test, process and deploy the package and run the integration test upon it. Verify is going to check the package, and it is going to do some verification that's good, package is good or not. Install means it has generated the package now. It is going to install that package into Maven cache. What is Maven cache? We'll get that. And the deploy. Okay, so Maven has validated, compiled, run the test, verified everything is fine. It has installed the package into local cache. Now let's deploy this package to the central repository, which, what is that? I'm going to get there in a while. So this is the standard lifecycle of Maven. Maven has plugins associated with each phases of lifecycle. For example, to validate, Maven has its plugin. To compile, Maven has its plugins. So now let's see where are those defined. So I'm again in the project directory. I have the pom.xml right next to me. I'm going to run the build up to the clean phase of the lifecycle. So it is going to validate. Clean is not a phase. Know that. Yeah, so let's see the pom.xml in the detail. Here I am saying that Maven run the help plugin, and the goal is effective pom. So it is going to render the effective pom. So as you can see that even if we just had this thing, Maven by default provides some configuration. So this thing are copied over. So here you can see that clean plugin is provided by Maven to invoke the clean thing. For the compiler phase, Maven has binded Maven compiler plugin, which is binded to the compile phase here. With the test phase, it has binded Surefire plugin. Install phase has this. So each of the phases has its own plugin binded to it. This is the default build look like for the Maven. You can customize it the way you want to. Now let's get back to those two things that we just skipped, Maven cache and Maven repository. Maven cache is it's a simple directory that is there in your home directory .m2 and repository. It has all the, so when you do that, when you say that Maven, I need JUnit to compile this project, it goes to the internet and downloads the JUnit for you, but it doesn't do it every time. It downloads it for you and it puts it here, and for the further execution it refers it until it times out as it is configured. So this is where it puts all the artifact, and this is its local cache. And the Maven repository is another centralized resource for Maven to download something. So this is Maven central repository. So I am at the root here, and if I go to org Apache, so org Apache is the group ID and it has all this artifact under it. So let's say tapestry. org Apache tapestry is the group ID and it has artifact tapestry IOC. All of these are version. So when we say that Maven, I need this dependency, it will go to one of the repository which is configured and it will download the jar for you and it will put in the class path. Okay, now we learned that Maven build phases has each plugin associated with it. So now assume that you want to do something while compiling. For example, you want to create a file when you compile. I mean, you want to associate a new plugin that you are going to generate at the compile phase. So let's just, again, I'm going to invoke this command. This command says that Maven use the archetype plugin to generate a project with this group ID, this artifact ID, and the archetype template you are going to be referring to should be this. So it will create a project for us. Let's just create the project. Okay. So here I'm invoking Maven clean install. That means that Maven, first of all, invoke the clean plugin and then go up to the install lifecycle. So the clean plugin will delete processed output and the compiled data. For now, we have nothing, so we can just do mvn install. That is going to go through all the phases, validate, compile, test, up to the install. So here you can see that it is installing this thing into my local cache, and it has installed. So Maven is now aware of this thing, that there is something exists with this particular group ID, artifact ID, that it can use it now here. So let's define the build life of this project. So I am now editing Maven's build lifecycle to include this plugin's execution. Before that, let's just have a quick look at what this plugin does. Again, this is the directory structure of plugin project. Mojo is the thing that binds with particular goal. So we are interested in this thing. So it has a goal. The goal name is touch. And when you are going to invoke this particular goal for this plugin, it is going to execute this particular method. So you can do anything you want with this goal and this plugin, and you can bind it with any phase you want. So this gives you like lots of flexibility. By default, this thing is already templatized, and it's going to create a file called touch.txt inside the current directory, and the current directory would be my output directory in this case. So let's bind this plugin to execute. I want to execute touch goal with compile phase. Okay, this is so let's go back to the command line. Let's go back to the to render the effective POM again. If you render the effective POM again, it should have the build life cycle. Yes, so you can see this thing is binded with touch. Now let's do so I'm going to instruct that first of all delete all the output directories and go to the phase where it compile. So it has compiled and it has created this touch.txt in here. So this is how I modified the build life cycle and plugged a plugin with particular phase. So you can imagine that if you want to do something which is meaningful, I mean, this example is not going to make sense, but for example, assume that you want to generate a file which holds the particular information about build, like when it was built, from what machine, what time, what was the environment variable look like, and other stuff you want to dump them. You can just grab them through Java and you can dump it to the file, and you can pack it to the jar and push it there, and your app can read it then. This would be a useful example. Let's go to the Nexus. So again, as we visited here, Sonatype actually provides a tool called Nexus, which is the repository of Maven artifacts. So generally, when you are working for a company or when on an organization, you have the Nexus set up at your organizer level, which helps you share the code and the jars you release to the other developers by just specifying dependencies. So Maven will go there, it will look at your organization level Nexus. It will download the jar that is written by other developers, and it will provide you as a dependency to your project. This is how it helps you share and develop the code. Here are some URLs that you can visit if you are interested further. This is the homepage. This is where the source code is, and this is the receive record. I think we are done with the demo and the session here. Let's go ahead and let's start with the question thing. Hey, Hugo, can you hear me?
Yeah, I can hear you. I wanted to point out that a lot of people are currently muted. So first of all, Jigal, you can probably get out of your screen sharing mode so that we can actually see you again.
Sure.
And then everybody else, I think Ashish is not muted, but apart from him, everybody else is. So what we really need you to do is just go mouse over to the top of your screen and click on the microphone button, and that's going to unmute you. You don't have to do it. You don't have to do it unless you have a question, of course. So only do it if you want to talk to Jigar. So Ashish, did you have a question for us?
I think he's muted at the system level.
Oh, he just muted himself. Okay, so he was probably just unintentionally muting and unmuting himself. Are we looking with anybody else? Does anybody else have any questions? You guys can also post questions in the chat if you're having problems with unmuting yourself. So I'll post a message here, and you guys just mouse over to the far left and access the chat that way as well. You can, yeah, there we go. Jigar is just posting there as well.
Okay, I have a question.
Sure, go ahead.
How do you compare Maven with Jenkins? Have you used it before?
Maven with Jenkins?
Yeah. I heard a lot of Java guys talking about not Maven, talking about Jenkins. But I mean, I'm here because I never heard about Maven before. I mean, just the name, but never worked with it or never went through it or working with someone really working with it. But have you any experience with Jenkins, and can you compare it with it?
Sure. So to answer the question, I assume that you got up to the part where, like, what's the use of Maven? Like, how do you use it to compile Java project and stuff? How do you use Maven to do the build, compile, and testing for the Java project? Jenkins is a build system which you can use in your continuous integration environment. So assume that you have a project, you are developing a jar. You are using Maven to build it. So Jenkins' job in here would be to detect your check-ins, like into your SVN repository or into your Git repository, and build the trigger. And the trigger would be under the cover invoking the same set of Maven goals that you need the continuous integration environment to do. Assume that you are developing a jar which has a desktop application, and you are working on a part where you are developing service portion of it, and there is another developer who is working on the same application on the view side of it. So you made some changes to the service layer of code. You check them in. Now Jenkins detected that there are some change. So it goes there and it runs the Maven thing, which does the install and deploy. So now your code has been deployed to Nexus repository, and another developer who is willing to use your code, that's just the change that you made now, he would be able to pull it from Nexus. So Jenkins is more like a web-based CI tool in here. It is still going to use Maven under the cover to invoke the build. Jenkins is like more of build management and integration environment. Does that answer your question? Do you have any follow-up question?
Yes, I got the idea. So thank you for your answer.
I think we have another question in the chat. The question is, hi Jigar, can tell steps to create own Maven server where we can create a jar and other team of member can use it? Sure. So it's pretty straightforward. It's Nexus is under the cover, I guess, Tomcat based embedded web application. So it is again self-contained. You can go to Sonatype Nexus. You can just Google Sonatype Nexus. You can download the download the downloadable, and it has the script, wrapper script, which launches the Tomcat, and it spins up the Nexus. And then you need to configure Nexus to restrict and create some repositories. Also, you need to configure Maven to look at that repository instead of looking at the central by default. And that can be done by specifying the repositories tag in XML. I hope that answers your question, Ashish. Okay.
Hey Ashish, is there a reason? I guess maybe your audio is not working. So if if you want to try to fix your audio, you can always just close your browser. Even if necessary, restart your laptop and then jump back in. Usually the audio card, if it's not working right away, that's a good way of getting things moving again. But yeah, you can also communicate with us through chat as well.
I think he's saying that he's in.
Oh, so he can. That makes sense. Okay. That makes perfect sense. Yeah, well, let us know if you have any questions. You can also chat with us. Cool. So do we have any other questions from anyone else? Well, if you guys would just do me a favor and quick unmute yourself and give Jigar a quick round of applause, I think that would be really appreciated. He's done an amazing job. This was a very well prepared presentation. I really, really enjoyed it. Yay!
Thank you.
And we have a perfect recording now, and I'm definitely going to be going through some of these steps myself, and I hope you guys will as well. So if any other questions arise, you guys don't hesitate to reach out to AirPair. We can always connect you with Jigar. He's an expert, and he can help you out with anything you're working on. So once again, thanks everyone for joining. Jigar, thank you for putting this together, and I hope to see you at one of the upcoming additional webinars. Thanks, everybody.
Thank you.
Bye.
Bye. Thanks.
Bye.